Hi to all. In this video, I'm going to explain about the output equation of a three-phase induction motor. Okay, before going to output equation, induction motors. Induction motors will work in the principle of purely induction. We are not going to give any supply to the rotor. Only for the stator, we are giving the supply. Based on the induction, the rotor starts to rotate. That's why these motors are called induction motors. Okay, now output equation of three-phase induction motor. Three-phase induction motors. mm, Here, main dimensions are very important for the uh, all the motors or transformers. Okay, main dimensions we know. One is armature length and armature um, dia. Okay, these are the things are L and this one D. Length of the armature and diameter of the armature. These two are the main dimension for the three-phase induction machine. Now we go for output equation. Output equation is the mathematical expression which gives a relation between the various physical and electrical parameters of the electrical machines. Okay, in an induction motor, the output equation can be obtained as follows. Consider an M phase, and M here this is 3. Okay, with usual notations. Output Q in kilowatt is equal to input into efficiency. We know efficiency is equal to output by input. So from that, output is equal to input multiplied with efficiency. So input to motor is equal to M into V phase I phase cos phi, because it's a three phase AC circuit. So we have to multiply with cos phi. So M V phase I phase cos phi into 10 to the power of minus 3 kilowatt. Okay. For a three-phase induction machine, M is equal to 3. Input to motor. Now, instead of M, we have to substitute the value of 3. 3 V phase I phase cos pi into 10 to the power of minus 3 kilowatt. Assuming V phase is equal to E phase. Because supply voltage and the voltage which will be generated in stator will be a small losses will be there. So, let me consider more or less equal supply voltage and the voltage generated in stator, that is E phase. Okay, so V phase is equal to E phase, that is equal to 4.44 F by T phase kW. This is the formula for the E phase. So instead of T phase, if you substitute the value of Z, we will get 2.22 pi Z phase, because T phase is equal to Z by 2. Okay, so if you write instead of T phase, if you substitute Z phase, we'll get the value, the equation 2.22 F by Z phase kW. F is equal to we know Ns is equal to 120 F by P. From that, F is equal to Pns by 120. This is for RPM. Okay, if you convert into RPS, P small ns by 2, because we have to divide this one by 60. Okay, 120 divided by 60 will get 2. So the output equation 3 into 2.22 Pn by 2. Instead of F, we are going to substitute the value of Pn by 2, and pi is at Z phase, Kw, I phase, efficiency, eta cos pi into 10 to the power of minus 3 kilowatt. Okay, output is equal to, if you multiply this one, we'll get the equation 1.11 P5 into 3 I phase Z phase into small ns kW efficiency eta cos pi into 10 to the power of minus 3 kilowatt. Okay, so P5 we know is the specific magnetic loading, BAV pi DL. Okay, so and 3 I phase Z phase by pi d is equal to q. Okay, so output of motor 1.11 multiply with VAV pi dl, multiply with pi d and ns kW eta cos pi into 10 to the power of minus 3 kilowatt. So this will be the output equation of the motor. Q is equal to 1.11 pi square VAV q kW eta cos phi into 10 to the power of minus 3 d square L n s kW. This term we consider as a coefficient of output equation. Okay, 1.11 1.1 BABQ d square lns kW. Therefore output q is equal to c naught d square lns kW, where C naught is the output coefficient of the motor. So 1.1 BAV Q kW eta cos phi into 10 to the power of minus 3. V phase is nothing but phase voltage. I phase is nothing but phase current. Z phase is the number of conductors per phase. T phase number of turns per phase. Ns synchronous speed in RPM. Small ns synchronous speed in RPS. P number of poles. Okay. Q specific electric loading. Phi air gap flux per pole. BAV is the average flux density or specific magnetic loading. Okay. KW is the winding factor. Eta efficiency cos phi power factor. Capital D is the diameter of the stator and L is the cross length of the rotor. Okay. C naught is the output coefficient. So here mainly we are going to find for L. L means the length of the armature and D. D is nothing but diameter of the armature, that is the air gap present no from this air gap to this air gap. Okay, so this will be the length. The length of the stator and length of the rotor will be equal, so we can take any one of the um, length. Normally we should take the armature, the rotor length and that rotor diameter for the main dimensions of the three-phase induction machine. Okay. Okay. Thank you.